Okay, the last 15 minutes of the class of April 8th, we're working on the problem y equals 2e to the x squared plus 1 to the third. It looks like a very complex problem. We want to simplify it. So what I'm going to do, the first step is divide both sides by 2. I have a reason for getting the 2 out of there. I'm going to have y over 2 equals e to the x squared plus 1 raised to the third. Correct?
Looks good to me, Dr. Mirabile.
Now, I'm going to take the natural log of both sides. I'm going to use two logs. I'm going to use log rule 2 here. And I'm going to use log rule 3 here. Basically, this is the natural log of x raised to any power. Even if there's a squared there, it doesn't make any difference. Would be equal to a squared, the natural log of x. Over here, we have the log of y over 2 is a division rule. We have the natural log of the denominator of the numerator minus the natural log of the denominator. And that's what my function looks at this point in time. So I really have here log of y minus natural log of 2 equals, in this case, x squared plus 1 to the third, the natural log of e. Now let's do some cancellation. Let's see, the natural log of 2, I had it down here somewhere, is 0.693. This is the natural log of y minus 0.693. Write it down right.
Did you say 693?
693, yes. Nice. No, hold it. 693, no. Let's see. Where are you? Yeah, 0.693 is correct. Equals x squared plus 1 to the third, and the log of e is 1. So what do I have here? I'm going to write this back on top because getting to the below the board tends to shake it up a little bit. So let's write this back on top. Well, what we have now is the natural log of y minus 0.693 equals x squared plus, is that 2 or 1? Was it 1? 1. 1 to the third. I want to find the derivative of y with respect to x. Now we're going to run into a little problem here. The reason I introduced this, because we're covering implicit differentiation. So that means I'm going to have to take the derivative of the log of y with respect to x, which I really can't take because I have a y here and an x here, as we said before, minus the derivative of a constant, which is 0, and the derivative of a polynomial, which is just a basic chain rule. So let's see what we have now. Let's erase this. And let's see what we can do now. Well, this is 0. Let's work. Now what about this? Well, this is a chain rule, right? So u equals x squared plus 1 du dx equals 2x A, which is the number in front of there, is 1, and n equals 3. What's the formula for the polynomial chain rule? Which I didn't put on here, was dy dx equals na u to the n minus 1 times du dx. Well, let's substitute that in here. That's 3 times 1, 3. U is going to be 3 minus 1. And du dx is going to be 2x. Substituting back for u, we get 3 x squared plus 1, 2 times 2x, or 6x x squared plus 1 squared. That's this guy right over here. So now what we have is minus 0 equals 6x x squared plus 1 squared. But what about this guy? I cannot take the derivative of y with respect to x. Here I use my chain rule formula. Remember I gave it to you, df dx is equal to df dy dx. I put that in here. That gives me the derivative with respect to y of the natural log of y tacked on to dy dx as an appendage. That's what I want to find. My whole thing here is to find dy dx. Remember, the problem set to find dy dx. What's the derivative of the log of y? Well, if you look at the rule, it's 1 over y. Equals 6x x squared plus 1 squared. Multiply both sides by y. And dy dx equals 6xy x squared plus 1 squared. And there's your answer. Notice I had to use implicit differentiation. That's what this is. This is implicit differentiation. Because I can't take a function y and take the derivative with respect to x. This is my answer. Notice I have x and y in here. In order to solve it, I would have to need to know x and y. But anyway, this is actually the easiest way of solving this. If you do it another way using u substitutions, it takes about 3 pages. So the easiest way to solve this is to actually use the log rules, and then you'll find out that you get a weird problem where you have a log on one side and a polynomial on the other. So you use the log differential rule that side, natural log, and the polynomial chain rule on that side. So anyway, that should give you your answer. This is your answer. This is a hard problem. I would suggest that you write this down in your notebook, put it somewhere, and then just write the problem down itself and see if you can solve it the way I did it. Okay? Get used to this. Own this problem. You're probably going to see another one like this on the final. They like to give it. Very similar. Okay. Let's erase the board and go on to section 11.3, which we had covered before. And we were into 11.5 actually. And we were talking about elasticity of demand.
5 minutes.
Okay. We're actually at 11.5. I did one problem. I'm going to start another problem on 11.5. I did a lot of problems in logs and stuff like that because I think I didn't do a lot when I went over it before. So let's put a problem down. We probably won't be able to finish it today, but let's put another problem down where we want to find elasticity of demand. And I'm just going to my where we left off, and here we are. Okay. So, example. Given P equals 1,000 over Q plus 1 squared. And I know that P is 19. P is the profit per unit. And find the elasticity of demand for this function. A, B, interpret your results.
3 minutes.
Now, what is the elasticity of demand equation that we really need? That is given like this, minus P over Q. Notice dQ dP. Well, I'm given P equal 19. Step 1, if P equals 19, find Q. Well, we find Q by going back to the original problem, equation 1. So P is given as 19. This is given as minus 1,000. And this is given as Q plus 1 squared. In this case, I would cross multiply. The idea is to find Q. That's going to equal to minus 10,000.
1,000.
What is it, 1,000? It's going to be not minus. It says no minus. It's just plus, right? Yeah. Okay, so it's 1,000. That's it. So now divide by 19. Q plus 1 squared equals 1,000 divided by 19. I'm not sure that I did this. So we can do this. How much time do we have?
1.5 minutes.
Okay, where's my calculator? Okay, my fault. I should have done this when I prepared the notes. This is when I missed. 1,000 divided by 19 is 52.6. What do we do now? We take the square root of both sides. So Q plus 1 equals plus or minus the square root of 52.6. The square root of 52.6 is 7.3, but you're just going to take the positive one. So Q equals 7.3 minus 1, or 6.3. So what we have here, Q and P equals 6.3 and 19. And we will finish the problem when we come back the next class.